Hello everyone, I'm Dave Thomas, and today I am building the 2.2 inch Iris scale model rocket by LOC Precision. This is an intermediate power or mid-power rocket, has a 29mm engine mount, which means it can actually fly on anything from a high thrust E up through potentially an H or an I. So you can fly this at high power if you are so certified. Now, they call this an advanced complexity model, not because of the build, but if you're going to do this as a scale model, the paint job on this takes a lot of skill. Now, I'm going to tell you up front, I'm not going to do it, because I bought this model mainly because it's a payloader, and I'm going to use it as part of my research program where I am sampling bacteria from the atmosphere using a compact vacuum pump type of system that will fit into the payload bay of this model. Okay, so I bought it for its structure, not for its paint job. One of the first things you're going to want to do is go to LOC's website, and you can use this QR code that's on the package, but that's the only way you can get the instructions. And so I've done that in advance and printed out the instructions here. They're very basic instructions, and I highly recommend reading through them thoroughly before you even start the rocket. That said, let's go ahead and open this up and make sure we have everything. Alright, we should have two tubes in here. We have the main body tube, and it has stuff stuffed inside of it. Quite a bit of stuff. Okay, that is pre-slotted for the fins, and inside there we had the engine mount, and there's stuff inside of that as well. Alright, so we've got two decals that were hidden inside the motor mount, so if you can't find the decals, that could be where they are. Alright, also in here we have a bulkhead and screw eye. This will go on to the payload bay. Alright, we have a coupler that will couple the payload bay to the main body tube there. And then in small parts package we've got the parachute, launch lug, rail buttons, shock cord, parachute protector, and a generic LOC Precision decal. Okay, still in the bag here, we've got centering rings for the motor mount as well as the base for the shock cord. So this uses a hybrid shock cord where attached near the motor mount we've got a Kevlar line, and that goes onto a screw eye there, and then we'll tie that Kevlar cord onto a tubular nylon cord that we saw earlier. Okay, we have 4 plywood fins. Alright, our payload bay, nothing in that one. And we have a nose cone, and they call this a polyethylene enhanced nose cone, which means it's a pretty strong nose cone, but it's really hard to paint it. And so I'm going to talk about sanding this and priming it in preparation for paint, because most paints don't stick to polyethylene very well. Alright, so coming back and checking, this says we have a polypropylene nose cone, the package says polyethylene enhanced. Both of them have the same problem of not sticking to paint very well. Alright, we've got that. Alright, looks like we have everything on the list. So we will go ahead and put most of this back for the moment and get started with building the motor mount. As I was getting ready to do this, I found a discrepancy. So in my centering ring package, it only has 2 centering rings, and it's supposed to have 3. And then the motor mount is supposed to be 12 inches long, and this is only 6 inches. So I could build the kit with this, barely, but I'm going to go ahead and contact LOC and see if they can send me the correct parts. LOC Precision got back to me within just a couple hours, and it turns out that the instructions are old and the kit has been updated to use fewer materials here. Basically, it makes it a little bit lighter, and that's great. So hopefully they'll actually be updating their online instructions soon. The first thing we need to do is roughen up the outside surface of the motor mount, and this is so the glue will hold better. And you can do this with anything between about 60 and 100 grit sandpaper. So just go ahead and take this all the way around. Now you don't have to do it really deeply, just enough to take the gloss off. Okay, now coming back to the instructions, they don't actually give us any particular measurement for where these are supposed to go. Instead, they recommend using the body tube fin slots to get an idea of what we need. Alright, so there's a slight difference here in the centering rings. One has a hole in it, and that will be the forward ring. And the other has no hole, that'll be the aft ring. And both of these are really tight, so even after sanding that, we've got some tightness here we need to take care of. And so I'm going to take that 100 grit sandpaper here again. I'm wrapping it around an old motor just to act as kind of a handle, and I can stick this through and just run this around as I sand the inside surface here. Okay, and we want them fairly snug, so that's going to work there. And on this one, looks like we need a little sanding there as well. There we go. Now I'm going to mark one end as aft so I don't get these mixed up later on. So that's the forward end with that hole in it. Now the model does not come with any type of motor retention. So you're going to need to have at least a fair amount sticking out here if you're going to use a method where you simply put the motor in and put tape around it. Okay, which you can do with most composite motors. We also need to make sure that there's enough space between the forward and aft centering rings that it doesn't interfere with the fin slots. Now here we got a little bit of cardboard still in that one. Just pry that out. Okay, so dry fitting this in. Okay, that's kind of tight. Looks like we may need to do the outsides of our rings as well. Alright, now we'll try that once more. That's the ring. I think we've got a little bit of material down in here. So here you can take your thumbnail, or you can take like the handle of a hobby knife here. Just make sure you don't stab yourself with the blade. And just kind of chamfer that edge, squashing down there. There we go. Alright. So there you can just see the edge of the centering ring. The other centering ring is up there a bit. Okay, now I am going to use an Estes 29mm motor mount. I should say motor mount retainer. All right, this is made out of plastic here, probably polycarbonate. And so that requires that much space at minimum there. Okay, so I'm going to leave just a little bit more hanging out, just to make it easier to get the motor in and out, and to mess around with the retainer there. Okay, and I'm going to bring this in a little bit, and I'm going to measure it on the outside first. Now I like to have this as close to the slots as I can, because when we go to put the fins in, that way we can actually epoxy the fin tabs onto the centering rings, and that gives us extra strength. So we want to get this as precise as we can. Okay, so now if I slide that in, okay, we should bring that ring right there. Okay, and we can actually bring that forward ring in some more. Okay, and now if you want to make it extra sure, take one of the fins here and just pop it in the slot. Now these may also require a little bit of sanding. There we go. Okay, but that should fit nice and snug in there. So I think we are ready, we're almost ready to put this together permanently. Now I was just thinking something else that you might want to consider is to take the aft end here and actually give it a little more extension outward and bring this up. And the reason I say that is so that you can get the screw eye that goes in here in relatively easily without bumping into the tube all the time. It really won't hurt much to have a little extra extension out back, especially if you're not using a motor retainer. Bring that back a little bit. Alright, spend a lot of time getting this just right, but it's well worth it. There we go. Okay, so now I'm going to go ahead and mark these. So I've got a reference line. Now when we put this together, what we're going to do is bring the rings inward, put epoxy on them, and then bring them back outward again. And the reason for that is to not get epoxy residue on the inside part here. Because if you do, when we go to put the fins on, come on, fin. When we go to put the fins on here, if there's epoxy in these corner edges here, that will prevent the fin tab from seating properly. Okay, now they do suggest using epoxy throughout this. Frankly, you could probably use wood glue on all of this, but just to be safe, I'm going to follow the directions and go with epoxy here. So I've made up some 5-minute epoxy. I'm going to go ahead and apply that now. First to the forward centering ring. I'm going to do this fairly quickly. All right, so we'll just kind of slather that in there. Alright, and I'm going to move that forward all the way up to the line. Okay, now I'm going to do the same thing on the aft ring. I'm going to pull that ring back. Okay, then we'll push that one back to the line as well. Alright, and then I'm going to use my fin tabs here as a guide. Make sure that we've got equal spacing all the way around this. And you can either do this now or do it later. I'm going to go ahead and epoxy on my motor retainer. So here we're just going to take some more epoxy and put it around the tube here, making sure we don't get it inside. And we want the excess to get pushed down toward the centering ring. All right, and really quickly I'm going to sand the inside of this to make it grab the glue better. Should have done that beforehand. That's okay, we got it. All right, I'm just going to slide this on and turn as I go. Okay, and that should have no gook inside there. Alright, check the fins once more. Everything looks good. And now I'm just going to let that completely harden, and we'll come back when it's done. My epoxy has hardened, and I had a little bit of it get into the hole there where the screw eye is supposed to go, so I just re-drilled that with a 1/16 inch bit. Okay, and now what I'm going to do is just screw this into the hole. Now, a little while ago, I had a viewer ask me if you could put the screw in so that it is perpendicular with the edge here, so that you could more readily change out the shock cord. And I said, well, you can if there's enough clearance here. Now this one does not have that kind of clearance. In fact, this is bonking into my motor mount tube there. All right. Having the epoxy on this is making this job a little harder. Okay, but not only does it hit the motor mount, if we look at this in profile, it would also hit the body tube there. So at least in this case, when we're finished, we want it to look like this. Okay, and that's about where I want it, maybe one more turn. I like to have at least one full turn of threads remaining up here on the top. And now we're going to get a little bit of epoxy to cover this up and lock it in place. So I'm going to mix that up quickly and I'll be right back. Here I've made up a small batch of 5-minute epoxy. And so if you want, you can unscrew the screw eye, put a little on the threads and then screw it back in. I'm just going to put it directly on the threads here. Okay, and then I'm also going to put it on the upper threads up around here. And then if you want, you can also put some right here in the little gap on the screw eye. Close that up. I don't know how much it'll actually add to the tensile strength of it, but we'll try it there. Alright, I'm going to let that harden for a few minutes and then come back. My epoxy is setting. It's still not completely set, but we can handle it without any problem. So, as I mentioned earlier, this uses a hybrid system where it has a Kevlar shock cord that's attached to the motor mount, and then this attaches to a tubular nylon shock cord. If you would prefer to use just all Kevlar, you can do that. Just get a 15 to 16 foot piece of, this is probably 250 or 300 pound test Kevlar, and just attach this in the same way that I'm going to show you here. You just have a whole lot more of it, and then you can do whatever you want with the shock cord that came with the kit. For the purposes of this video, I'm going to go ahead and do this as the kit specifies. So the first thing I'm going to do here is I'm going to tie a loop in each end of my Kevlar here using a water knot. Okay, so we got one loop there. And another loop here. Alright, and then to lock those in place, I'm going to put just a little tiny dab of super glue on the knots. Just like that. Okay, and that'll soak into the Kevlar there and it'll keep it from unraveling. Okay, and then we can just dab off the excess here with a tissue. Okay, so now I'm going to take one of my loops. I'm going to put it through the eyelet here, like this. And then I'm going to take the other end and stick it through the loop. Okay, and pull that all the way through so that now we've got an attachment there on the screw eye. Now, if you want to keep this from slipping, you can put a little more super glue on there. Even if it does slip, though, as soon as you put tension on, it's going to come back together. So I don't worry about that too much. Now we're going to put this down through the motor mount so that it stays out of the way when we go to put this into the body tube. And that's coming here next. Now before we put the motor mount into the body tube, it's a good idea to mark the tube at this point so that we have a guideline for our launch lug and or rail buttons. And so I'm just going to kind of eyeball a place halfway in between two of my fin slots here. Okay. And on mine, I'm actually going to use both. Just simply because it gives me more options in the launch field. If I'm using other people's equipment, they may or may not have a rail or may not have a 1/4 inch launch rod. So I'm going to put another mark here on the opposite side so that at least the drag induced by either one kind of evens out. Okay, and I'm going to extend these lines all the way down the length of the rocket. So I'm going to go use a door frame to do this. You can also use a piece of angled metal, angled aluminum, angled iron to do that. But since I have a door frame handy, I'll just go ahead and do that off camera and come right back. I now have two lines that extend all the way up the length of the rocket. Now in the instructions, they have us make the launch lug line just 12 inches from the aft end and extend 12 inches beyond that. I prefer to have a full line there as it makes it a lot easier to align the launch lug. Now in this kit they use just a single launch lug kind of in the middle of the main section of the rocket here. And so we're going to first of all have a line, or measure our line here. 12 inches from the aft end. So that's going to be right here-ish. Come on, pencil. There we go. Okay, and then I'm going to use the launch lug itself. That looks way too high. I'm going to use that for the upper part of the launch lug. This looks much better to me. Okay, now alternatively, you can cut this in half and put one part of the launch lug down at the aft end and the other one up here near the forward end. The advantage to that is down here at the aft end, it's going to stay on the rod longer and so hopefully give you a straighter trajectory when it comes off. And also having the other half up near the forward end makes it more stable on the pad and less likely to crack off if you get a wind gust or something like that. Okay, I'm going to go ahead and just use the single launch lug here, but if my interpretation of the instructions looks like they're putting it way up here, and that's just too far. So I'm going to put mine there. I'm going to take my 100 grit sandpaper here and roughen up right along that line. And you don't need to do much. Again, we're just taking the gloss off there. And then we can do the same thing to our launch lug. And the instructions indicate to cut the ends at an angle to increase aerodynamics. I will do that when we're actually ready to put the launch lug on. And that won't happen until after we get the fins on. But I wanted to do this part while we're marking lines. If you're going to use rail buttons, the best place to put those is one will be down here at the aft end, and we'll use a wood screw to attach it directly onto that aft centering ring. And then the forward one will be about 10 centimeters down, which is far enough that it clears all of the coupler and the screw eye that will be in the payload bay so that it doesn't interfere with anything there. For that, I'm going to use a T-nut and a machine screw to hold that on. We'll do more of that later on in the build. I am ready to put the motor mount in, so I have mixed up another batch of 5-minute epoxy here. And what I'm going to do is place this right below the edges here of the fin slots all the way around the interior there, so that when I push the motor mount in, it'll push through the epoxy. Okay, so this is done a little bit blindly here. Okay, and then once I've got that, I'm going to slide the motor mount in, but not all the way. Now I'm going to put another ring of epoxy just inside the aft end. Okay. Now I'm going to turn this and first find the screw eye there and make sure I'm not on that. So I don't want anything blocking fins. And so now I'm just going to push this up until the two rings are on either edge of the fin slots there. You can adjust those as necessary. Alright, now some of this is just a little bit of epoxy sticking in there. We want to get rid of that. Give that one last adjustment. Okay, and now we will let this harden, and then once that's done, we'll come back a little bit later and put in a fillet around the aft end there. The 5-minute epoxy has cured, holding the motor mount in place. And as I said, we want to put some fillets along the edge here to fully seal in that centering ring. Now I'm going to do this a little bit differently. You can do it with 5-minute epoxy and like you normally would with a fillet. But I've mixed up about 4.5 grams here of 30-minute epoxy. I'm going to let that kind of just flow down in there. And the idea is that since this is a slow cure epoxy, it will basically go down and get into all the cracks and crevices, and then also kind of level out the surface here. So it'll fill in any low spots that the previous epoxy created. Now I do have to be careful that we don't get epoxy on the threads of the motor retainer there. Like I almost did there, that's just a little bit. Take that off with my glove. Now keep in mind, doing this is going to add 4.5 grams of weight to the total mass of the rocket here. But we'll have a nice strong joint there, and it's going to look really nice once it all solidifies and levels out. Okay, so I got a few spots here where I got epoxy where I don't want it. Now fortunately, being 30-minute epoxy, it's going to stay liquid for a while. And then we can remove unhardened epoxy with a little bit of rubbing alcohol. Alright, so I'm going to kind of shape this around a little bit. Kind of hurry the spreading of the epoxy. Okay, and I'm just going to take some tissues here and moisten them with some alcohol. And I can run this any place I got it on the threads. Like right there. And then I'll also run it right along the edge here, just in case any got on the outside of the tube. Okay, so now we'll just let that harden for the next half hour to an hour before we go on to the next step. While I'm waiting for epoxy to harden on the motor mount, I'm going to turn my attention to the nose cone here. Now this nose cone was made in 2 sections, and we have a very prominent seam here. We've also got some little projections here that came from the molding process, and we want to sand all those down. So I'm going to start with some 150 grit sandpaper here, and initially I'm just going to concentrate on these high spots, so the 2 seams and then these little knobs in here on the sides. Alright, so let's knock down the high points. And you can see here there's some low areas on either side. This is actually still sticking up a little bit. But most of those nubbins I've ground down. I'm going to do a little bit more here. Okay, so I'm just going to continue a little bit and still with the 150 grit sandpaper, see if we can knock some more of these down. Okay, now I'm still using the 150. I'm going to go all the way around the nose cone so I have a uniform toothiness to it. And in the end, this is going to help the paint stick to the nose cone. Now you can see here that the plastic does kind of melt itself onto the sandpaper here. Alright, so you may need to kind of brush that off. When we get this done, we're going to do some finer sanding, but we'll use wet sandpaper for that. Okay, so that's how it looks after fully sanding this with 150. Now I've still got some seam here, and that's actually still sticking up. Hit that just a little bit more. Okay, and you can continue doing this and sand all the way so that seam's gone. But you have to be careful that you don't get so much sanding that you thin the wall so much that you lose some integrity there. And what I'll be doing here eventually is spraying this with a filling primer, and that will fill in some of these imperfections as well. At this point, I'm going to go over to the sink. I'm going to continue sanding this, first using 220, then 320, then 400 grit sandpaper, and that should give us a nice smooth finish by the end of that. Here's my nose cone after wet sanding with 220 grit sandpaper. And so the scratches now are much finer and more even. You can still see the seam here. All right, as I said, that the finishing touches on that with sealing or with filling primer will get rid of that. So I'm back to the sink and the sandpaper, this time with 320 grit. Here I've done 320 followed by 400 grit wet sanding, and if you're expecting this to be polished, it's not. The idea here is to have very, very fine scratch lines, and that gives the paint something to adhere to. Once this is primed and painted, it'll look nice and smooth. Something else we can do while we're waiting for epoxy to harden is to assemble the payload bay. Now in this case, I'm going to do mine a little bit differently. The normal way to do this would be to assemble this bulkhead, which we will go ahead and do. Alright, so I'm going to start by just threading the eyelet into the bulkhead itself, just till it comes out. That way we've got threads. Okay, and then once that is done, we would install it in here with some epoxy, and then we'll also find the halfway point here, and we do need to do this anyway. So just take a ruler, and this is probably 6 inches long. Not quite. Let's see how it is in metric. Okay, about 14.5 centimeters, about 7, I call it 7.3 here. Should be about the midpoint. Alright, so for the normal assembly of this, we would then take either some wood glue or epoxy, put that inside the tube there, and then put this in until we get the halfway point, let that cure, and then you can either do the bulkhead before or after, but that'd go down here in the end of the coupler, and that would give us a really big payload ability there. Now this can be set up for dual deployment. I'm not going to go into the details of that, but you can make it such that you can do either way, either a single or a dual deployment, by using removable plastic rivets instead of gluing this into place. And that's what I'm going to do with mine. So here I had already started the threads through this. I'm just going to put a little blob of wood glue here. You can use epoxy if you prefer. But for this particular joint, either is going to make a nice strong joint. So then I'm just going to thread this through again. And I'm going to twist this in until I have about 1 full turn of thread showing there. And then on the back side here, I'm just going to cover that threaded portion there with a blob of glue. It doesn't quite have to be that big. So I'm going to spread this around a bit. And if you want, you can just do this. And give a coating of glue. Okay, and if you want to do it on the back side as well, you can. I'm not going to do it. But I'm going to let this dry now, and we'll come back when we're ready to put it together. This next part will need a flexible tape, so like a tailor's tape here. And first we're just going to measure the circumference all the way around here. Okay, so that is about 18.2 centimeters. All right, now I'm going to call it 18.3. Is it that little fudge will just make it easier to measure around here. So we're going to divide this into 3 sections, and each one of those will be 6.1 centimeters. So here I'm just going to mark at 6.1. And then at 12.2, right here. Okay, and then back over here at 18.3. So those should be 3 equidistant points there. Okay, now I'm going to take my tube marking guide, and if you don't have one of these, you can just use a door frame. But for each of those marks now, I'm going to draw a full line the length of the payload section. Now again, if you're just going to glue yours in place, you don't need to do this part. And even if you do glue your coupler in place, you might want to do this for the nose cone. I'm actually going to do both here. Okay, so the idea here for the nose cone is you can put this in, and instead of trying to rely on a friction fit with masking tape and things like that, you can actually use those rivets to positively keep that in place. So we've got lots of room on here, and I am going to put my rivets fairly well down. I'm going to say at about 3 centimeters there. And here I'm going to have to mark this. I'm going to mark one end inside aft and the other side as 4. That way I don't get them turned around. For the back side, the aft side of this, I'm not going to want the rivets up quite so far. Okay, so here I'm going to measure on my forward end. Along each line, I'm going to mark at 3 centimeters. Okay, and then back here, on the aft end, I'm going to do them at 2 centimeters. And there's no specific reason for the measurements I'm doing. I'm just kind of estimating where things like a payload would be inside of here. And that's just based on my own past experience. I may be completely off. Now for the reusable rivets, these come in a multitude of sizes. They're available from Amazon. There are several rocketry retailers that also sell them in smaller packages if you don't want to buy them by the hundreds. I know Apogee has them. I think maybe Launch Lab does too, but I'm not sure about that one. The problem is they're in metric sizes, and usually drill bits are not, so you have to kind of match them to it. This is a 5 millimeter diameter by 6 millimeter long rivet. And so we're just going to try and get as close as we can. And at first it's better if you underestimate. Because if you get the hole too small, you can make it bigger. If it's too big, it's really hard to make it smaller. So I'm going to start with a 3/16 inch bit here and drill the holes and then see if that fits. If it does, fine. If it doesn't, we'll go up to the next size. And we do this carefully so we don't end up drilling a hole through my mat as well. Alright, so 3/16 is really tight. Could probably force it if we needed to, but I'm just going to move up one fraction here to a 13/64. Alright, and then we'll just drill that out. Alright, and that does fit. So now I'm going to go ahead and assemble this. So I'm going to put my nose cone in. I'm aligning it. You don't have to align it to anything, but I'm doing it there. I'm going to put on some masking tape so this does not move. Okay, so I'm going to re-drill this hole so that now it goes down through the nose cone. And so that should pop in there without any problem. Now I'm going to do the other ones with the nose cone in place. And you saw that one moved a little bit. It's not a big deal. It just means that this is only going to go in one direction. That's okay. So now we pull that out, make sure all those holes are nice and complete, and we can put this back in again, line up the holes. Okay, now what happens with these is when you push the rivet in, it expands these little tabs here, and that's what holds it in place. I'm just going to do one of them here just to make sure everything's working all right. All right, and then that just pops in like that, and now that's holding that nose cone in place. Now to get them out, sometimes you can just use fingernails, sometimes you may need like a knife blade here to pop that up. This one's doing really well and holding exactly how it should. Alright, that broke. Sometimes that happens. Get it out. Now I think what's happening is that this is going right at the level of the nose cone plastic thickness. And so to get around this if you want, you can use a longer rivet. Okay, I got that rivet out, and what I've done is now changed to an 8mm long rivet. It's still 5mm diameter, but I've already done this, taken it in and out and everything. It works great. So you just need a little bit longer rivet because of the plastic here. I'm going to use the 6mm long rivets for the cardboard tube yet, though. Okay, so I'm going to go ahead and take off the nose cone for the moment. And we're going to slide in the coupler. And that coupler is kind of loose, so we're definitely going to want to have some masking tape on that one. And as before, we're just going to drill down through here. Now we can test these rivets, and these should go on really easily. They just pop in there. Okay, and then we'll push it in. Okay, and that's holding nicely. Now these should come out easier because it shouldn't have the restriction of the nose cone plastic on them. We'll see here. If these ones are getting stuck as well, we'll just use the 8mm all the way around. Nope, there they go. Okay. Now something else we can do on this to make it more durable, because if you have to open this a lot and change things out, eventually those cardboard holes are going to start wearing out and they won't hold the rivets any longer. And so what we can do for that is just take some regular super glue here. And I'm just going to put it right inside here so that it saturates the cardboard around the hole. Okay, and even get that raised stuff, because what this will do, once it dries, it'll make that cardboard really hard, and we'll be able to just file out the stuff that's sticking out on either side, and that'll give a smooth finish, but also a more resilient hole that should hold its shape and measurements longer. Okay. Usually when you do it, it'll automatically get enough to the inside, but if not, you just go ahead and add some to the inside there. I'm going to do the same thing to my coupler. Now I'm going to let all that stuff dry and start working on the fins, and eventually once the glue is dry on the bulkhead, we'll go ahead and mount it as well. The glue is dry on my bulkhead and we are ready to glue this into the coupler. Now again, you can use either epoxy or wood glue for this. Okay, so here we're going to make sure we're on the right end, so this is the aft end. Nope. This is the aft end. Okay, so we're going to run a bead of glue right along the edge here. Okay, now when we put this in, we're going to kind of put it in at an angle. And that'll let us get that edge in. This is really tight. I forgot to dry fit it. So fortunately it does fit, albeit tightly there. All right, so we'll just press that into the glue. Now if yours is too tight, go ahead and sand the edge of the wood there. Once you've got that in, go ahead and put a fillet in there. And then if you want, you can go ahead and spread glue all over this. Give it a little bit of protection from the ejection charge. Just kind of smooth this around. All right, and then if you get any on the outside of the coupler, be sure to clean that up. Okay, now we can let this dry, and when we come back in part 2 of the video series, we will start in on the fins.